Hey guys, today I'm going to explain what is insertion sort and how does insertion sort work. Insertion sort is normally used by most people while they are sorting their playing card, particularly clear if they are picking up one by one and putting them in place. The idea behind insertion sort is to loop over position in the array, starting the index of 1. Each new position is like new card handed to you by the dealer, and you need to insert it into the correct place in the sorted subarray to the left of the position. Here is the algorithm and the example question for insertion sort, which we will go through step by step. So the first step is for the counter of I set to the value of 1 because insertion sort always start from the index 1. The value of 6 is the size of the array, and then the temp here is to temporarily hold the array value, which our array value here now is 8, so the temp is holding the value of 8. J is equal to I, so the J is equal to 1. While J is larger than 0, which this statement is true, and temp, the value of 8 is smaller than array J minus 1, a value of 5, which is false. In this case, it doesn't meet the condition, so it will go through the while loop. So we will loop again in the for loop. So now our I has been increased into 2. Our array index of 2 is the value of 3. So now our temp is storing the value of 3 here, and then J is equal to 2. While J is larger than 0, this statement is true, and 3 is smaller than the value of 8, which is also true. So we go into the loop. Now array J minus 1 is pointing towards the index 1, is set equal to array J. That means the index 2 value will be replaced with the value of 8. Now the J has been decreased by 1 here at this statement, and then array J is equal to temp. So our temp is holding the value of 3, so it will be override and the position will be swapped. We go into the third step. You can see that we will still go back to the while loop to check if it met the condition or not. If it doesn't meet its condition, we will straight go to the for loop. So now we will check again. Is our J larger than 0, which is true, and the temp is holding the value of 3 is smaller than the value of 5, which is also true. We'll go through the same process again. Set the value of the index of we set the index 0 value to the index 1, and then decrease the J by 1, and then set the array J, which is pointing towards index 0, and assign the value of the temp, which is 3. So the value of 5 and 3 have been swapped again. So we'll check again here whether we met the condition of the while loop. So J is larger than 0, which is false here. So we can straight away go to the for loop. The for loop here, now our I has been increased by 1. So the array with the index of 3 is pointing to the value of 15. And then our J is equal to 3, while J is larger than 0, which is true, and temp is 15 smaller than 8, which is false. So we will skip this part and then loop again. At the step 6, our I has been increased once again, and then now the temp is holding the value of index 4, which is 27 here, and then we'll check the while loop again. Is j larger than 0? Yes. And then is the temp 27 smaller than the value of 15? False. So we'll loop again. At the step 7, the I has been increased by 1, so array and then index of 5, so it's pointing towards the 11, the value of 11s, and then j is equal to 5. While j is larger than 0, which is true, and temp is 11 smaller than 27, which is also true, so we'll go into the while loop again. And then array j minus 1 is the index of 4, and then is equal to array j, which is index of 5. So the array of index 5 will be override by the value of 27 here, and then the j will be decreased by 1, and the array j, which is currently holding the index of 4, is equal to the temp. The temp is 11, so the position of 11 and 27 will be swapped. So we'll check again for the check condition. If is j larger than 0, yes, it is true, and temp is 11. Is 11 smaller than 15? Yes, it is true again. So we'll go into the loop. Array j minus 1, so that means pointing towards the third index, and then array j, so array index of 3, and the array j means index of 4, you have the value of 15. Now j has been decreased by 1 again, so array j, now is array index of 4 is equal to the temp, equal to 11, so it will be override and swap of the position, and then that's the final answer that we will get. All the number in the array, all the value in the array will be in ascending order.
Hello everyone, now I would like to talk about the efficiency of using insertion sort and when we should use insertion sort. Below are the 3 efficiency ways by using insertion sort. First, it is simple to implement because it is easy to understand by just insert and compare the numbers. After that, the numbers just need to rearrange back by ascending or descending order. Second, it is efficient for smaller data sets because smaller data sets can be easily applied the insertion sort. If the data set is big, we may face some error and problems while we arrange the data compared to the smaller data sets. However, it is still simpler and easy to understand compared to the other sorting method. It is good and easy to learn for beginner to understanding sorting. Next, I would like to talk about when we should use insertion sort. We can use insertion sort when there is a small array between 20 to 30 elements because it is faster than other sorting methods. Besides that, it has less comparison between the numbers. From there, we can know that insertion saves time compared to other sorting methods. That's all for our presentation. Thank you for your time for watching this video.